Hi, hello, welcome to Knowledge Center. In this lecture, we shall understand about the architecture of 8051. As you all know that I have started the microcontroller chapter in my previous video. There we have just compared the processor and the controller. Now in this video, let me make it very clear about the architecture of 8051. So if you want to write a programming in a microcontroller, first you need to understand the hardware components of it. So this architecture will give you an idea about the hardware component which it consists of. So watch this video till the end to understand each block of an architecture. Here you can see the block diagram or an architecture of an 8051. This can be called as an architecture or a block diagram. See, generally in architecture is nothing but what? That has to give the information, a complete information about a microcontroller. So this is going to give you the complete content of a microcontroller. See, microcontroller, any other processor or a controller must have a CPU. CPU is nothing but a central processing unit. So this central processing unit will be consisting of so many registers like register A, register B, data pointer, program counter, stack pointer, PSW, and so many further registers like R0 to R7, right? So these are all used to do some specific functions over there. So we can take the CPU separately in the next lecture, and there I will explain each content of the CPU in detail. Okay. Now just understand that CPU is nothing but what? It is a central processing unit which is going to have an arithmetic logical unit also. It performs some arithmetic and logical operations in it, and that will be stored. The result will be given to the memory. Okay. So this CPU will be working like a brain of our body. If you consider the body as a microcontroller, then our brain will think logically, arithmetically, right? Same way, the CPU will behave like a brain of this architecture. Next we have an oscillator here. This oscillator is connected to CPU. See, what is that oscillator will do? Generally we know that oscillator is going to oscillate, means it will generate the pulses. Okay, here I have a crystal and this is a crystal oscillator. This crystal oscillator will generate the pulses at certain frequency. Generally for this microcontroller 8051, it is 11.0592 megahertz. That is the working frequency of a microcontroller 8051. So what is that working frequency in this sense? Per second it is going to develop that much of pulses, 11.0592 megahertz, pulses per second or cycles per second, right? What is that actually pulse? Why do we need a pulse? Say the body, again I will consider my own body here. In our body, heart is very important. Heartbeat is important to live, right? So heart will pump, it will pump the blood, right? It will pulses, it will develop the pulses in a body, right? It will pump over there. Same way, here this is going to behave like an art of architecture. If our heart stops pumping, the body will stop functioning. Same way, if the oscillator stop generating the pulses, the whole system will get neutralized. It will never do any other task. Okay. So the pulses generated here will be like a heartbeats for this particular system. So oscillator can be called as a heart of an 8051 microcontroller. CPU, we consider it as a brain, and oscillator we consider it as a heart. Okay. Next here you can see interrupt control. Here we have one more block, that is interrupt control. You can observe these arrow marks over there. We have 3 from the on-chip ROM and we have 2 from external interrupts. I will give you basic idea about the interrupt control. See, we have 5 interrupts in microcontroller 8051. 2 are external interrupts and 3 are internal interrupts. Okay, and those 3 are provided to the interrupt control by on-chip ROM. Okay, ROM is nothing but what? Where actually we use for, this is the space which is used for coding. We write a program. That program has to be stored somewhere. So to store that program, we have ROM. Okay, so here we write a program, means by writing a program we can create an interrupt. That is called inbuilt or internal interrupts. Externally, if you get any interrupts, that is called external interrupts. First of all, let us understand what is this interrupt is. Interrupt in the sense, say you are doing a particular task. You are reading a book. You are reading a book and page number 28 you are reading. Assume that you are reading a book at page number 28. Suddenly someone calls you. Someone call you for to do some other task. Then what you do over there, you will just keep a pen or you will put some paper over there, or you fold the paper page number 28 and you close the book. Why you do that? So that we can, because you are stopping that process and doing some other task, right? So after completion of that task you have to come back to the page number 28. So there is a disturbance. You are reading but someone call you to do some task, some work. Say you are at home, your mother calls you to bring something else. Okay, so you close it and you will go. After completion of that task, you have to come back here, right? So that is an interruption for the reading. Same way, in the program, what happens? You will be executing certain code, certain program. Suddenly, some other device needs the service from the microcontroller. So service from the microcontroller in the sense that program needs to be executed now in between. Then what happens? The main program which is executing, that will be stopped over there, and the other program which is to be executed, that will be executed. And after completion of that execution, it will come back to the main program. So how all this will happen, that we will see in the interrupt chapter. Okay, in detail we will look into that. Now just understand that there are 5 interrupts we can create, 3 internal and 2 external. Internal in the sense, using the program we can create it. Actually we have 2 timer interrupts, 1 serial port interrupt. These are the internal interrupts, and 2 external interrupts. You will see it in detail in further lectures. Okay. Then we have an on-chip ROM. So on-chip ROM, this is for coding. On-chip ROM is for coding. This is made for coding. Actually, the size of this on-chip ROM is of 4K. Size of the on-chip ROM is 4K. Okay. So 4K in the sense what? K is nothing but it's not about 1000. K is nothing but 2 to power of 10. That is, K is nothing but what? 1024. 1024. Sorry, I will change the marker here. Just a minute. So it is 1024 into 4. Into 4. That is nothing but 4K. 4 into K. 4K. That much of memory is reserved for programming. So we have a huge memory for programming here in the microcontroller 8051. And look at these directions. These are all bidirectional. It will give the input here. This is programming code. This is a unidirectional. This is the only block which is unidirectional here. This will give the code, and program will be given to CPU. Okay. Further, this CPU will be interacting with the bus control and input output ports, serial port, timers, on chip RAM. And this interrupt control will also give the signal to the CPU. Right. Now let's see on chip RAM. On chip RAM is nothing but that is the memory or internal memory which is used to give the input. And the size of this is of 128 bytes. 128 bytes is the size of on chip RAM. We can also see on chip indicates that within that chip we have this much of memory. If you want to add some more, we can add it. That will be called as an external memory. But in this microcontroller 8051, inbuilt memory is of 128 byte RAM, which is used to give the inputs, give the data. This ROM is used to write a program. So understand the difference over there. Then we have the 2 timers. We have 2 timers in microcontroller 8051, and these timers will also be used for creating an interrupt. As I already told you here, 3 interrupts are internal interrupts, and among those 3 interrupts, 2 interrupts are created by these 2 timers, and 1/3 interrupt is created by serial port communication. Now let's see what is this timer actually. See, timer 0, timer 1. These timers are of 16 bit. The size of the timer is 16 bit. But as we know that microcontroller is an 8-bit processor. It will not deal with the 16 bit. But if it is a 16 bit, it will read it as it will split it into 2 8 bits. So it will be split into 2 8 bits like this. Okay, and it will name this as time TL0 and TH0. T stands for timer, L stands for lower byte, and 0. So timer 0 will be split into TL0 and TH0. Similarly, timer 1 will also be split into TL1 and TH1. It will split that 16-bit data into two 8 bits, lower byte and higher byte 8 bits, and it will make use of it. Okay. Timer, generally what we do here is, timer is nothing but that is a register which is going to count the internal pulses. It will count the internal pulses. So what is this internal pulses? Internal pulses means the pulses which are generated from the oscillator. Oscillator is generating a pulse. We can count that pulse. If we want to count that pulse, we have to use these timers. Any one timers. And that timers can be used in a different modes. Mode 0, mode 1, mode 2, mode 3. There are different modes of timers. So again, that in detail study will be done in the chapter where we will take up these timers. Okay, here just we have to understand that block and explain in detail about like this. It is a 16-bit but split into two 8 bits. Okay, and timer 0, timer 1 will have its own address that will also be discussed further. There are only two timers. And one more thing you need to understand here, I have mentioned something here, counter inputs. And inputs are given to timers. See, this same timer can be used as counter. The same timer 0 can be used as a counter 0. See, there is a slight difference between the timer and counter. If I am using it as a counter what it will do, counter will also counts, but it counts the external pulses. If I give some external input here, then it will count those pulses. It will not count the pulses generated by oscillator. If this is counting the pulses generated by the oscillator, then it is named as timer. If this is counting the pulse which are given externally, then it is considered as a counter. So I can name this as a timer or a counter based on what it is counting, whether it is counting the internal pulse or external pulse. Okay, so to control this means we need to have a control over the timers, right? Whether you are using the timer as a timer or a counter. To control this, we have a register called T-mod, right? We have T-mod register. Again, all these T-mod, T-con and timer related registers will be studied in the timer chapter. Now basically you need to have all this information. Next we have the serial port. Okay, first let me come from this part here. Bus control. Bus control means we will have two bus here. One is the address bus and the data bus. Means whenever you are fetching some data, you have to use the data bus. If you are just looking into the address, you have to make use of an address. So which is going to decide that? This unit is going to decide whether I am using an address bus or a data bus. That totally depends upon the CPU again. Okay, and what program we have written over there. It is interrelated. Then we have 4 inputs output ports. So these are important. We have 4 ports in 8051 architecture. Those ports are named as P0, port 0, port 1, port 2, port 3. In short, we call it as P0, P1, P2, P3. But here we have mentioned it as P0, P2, then P1, P3. Because P0 and P2 both can be used as an address or a data ports. Whereas these two are used as a data ports. Here, using port 0 and port 2, I can fetch 16-bit address. Okay. If you see, address can be 16-bit, but data is of only 8-bit. When you want to fetch the 16-bit address, I have to make use of 2 ports because each port size will be of 8-bit. Then what I do, I use port 0 and port 2. We combine those two so that 8 plus 8, 16. We get 16 bits, and using that 16-bit, I can fetch the address. So to fetch the 16-bit address, we make use of port 0 and port 2. That is the reason I have mentioned port 0 and port 2 to near each other, one after the other. After that, we have port 1 and port 3. We have some importance of these ports, like port 3 is also used for some dual purpose concept. That will be studied in the further classes, further lectures. We will take all this in detail in the further lectures. So in further lecture, I will also take in detail about the CPU architecture, how that CPU and what it actually consists of. I will explain in detail. Same way I will also explain about the ports. Don't be bothered about that. And these 4 ports are input-output ports. It can be used as an input as well as output. By default, when you switch on this supply to the microcontroller, by default all the ports will be behaving like an output port. Means if I give 0, it will be behaving like an output port. If you make it 1, if I give 1, it will be working as an input port. So don't get confused. 0 means output. This is how you can remember. 0 output. 1, that is nothing but I, input. This is how you can remember it. O, 0, O, output. 1 looks like I, that is input. Okay. If I make it as 0, by default it will be 0. So by default the ports will behave like an output port. Okay. We can give output to the external devices. If you want to read from the external devices, okay, then you can make this as 1 so that it will read. Okay. For that you have to do the programming, and where to do that program, where to write that program, everything will be studied when we take up these ports separately. Okay. Then we have another important block, that is the serial port. This is going to create another interrupt which I have mentioned here. 2 interrupts are because of timers and 1 interrupt is because of serial port. So these are going to use for creating the 3 internal interrupts. So serial port is nothing but it's a communication port wherein we can communicate something to the CPU, or we can read from the CPU, or we can write to the CPU. Okay. So to read we have, means if it is reading from external device, if there is some other system here from which if you want to read, we have to receive the signal. Serial port has to receive the signal. So for that we have receiving port here. We have receiving pin RxD, receiving the data. If I want to transfer the data to the another system, and then we will use this transmission data, TXD. Using this we will transfer the data. Right. So everything, these all will have the specific pin in a microcontroller. That will look in pin diagram. Okay. Now, as of now, I hope you have got a clear picture about the architecture of microcontroller, wherein these blocks has to be explained in detail. Just whatever I have explained over there, you need to write the same thing in the explanation. So in further lectures, we will take in detail about all these blocks clearly. For today's lecture, let us finish up here. The intention was to explain the architecture of 8051. I hope it is very clear for you. If it is clear, just press the like button, and also don't forget to subscribe to my channel. Thank you.